Okay, I'm going to work through some application problems. So let me share my screen. And these are taken from your homework, so it's not actually a homework assignment, but this is an excerpt from that homework assignment. So what we have here is in question 1, wind speed varies in the first 20 meters above the ground for a particular day. And then it gives you a function f of x equals 1.5 times the natural log of x plus 6.3. And that is used to compute the wind speed of x meters above the ground. So in this particular case, we are asked, what is the wind speed 11 meters above the ground? And then we're rounding the results to the nearest hundredth. So basically, all we're going to do is take that 11 and plug it into our equation. So let me do that. It's going to be 1.5. Let me clear this out. 1.5 times the natural log of 11 plus 6.3. Don't forget to close your parentheses, because if you don't close it and I do plus 6.3, it's going to take the natural log of 6.3 added to 11, and we don't want that. So make sure you remember to close those parentheses. And let me make sure I got that right. 1.5. Okay, looks good. So if we round it to the, what did it say, 100th place? Or did it say, let's see, 100th? Okay, so if we round it, it's going to be 9.90, rounding up because of the 6 there. So 9.90. Oh, it's a multiple choice. D is correct. All right. I'm going to skip question 2 because it's very similar to this question. You're just going to take this 10 to the negative 7 and plug it in. And if you take the common log of 10 to the negative 7, remember the log is the exponent and the bases match. The common log has base 10, so we know that this piece is just going to be negative 7. So you're going to have 160 plus 10 times negative 7, or 160 minus 70. So it's going to be 90. I just did that for you very quickly. Okay, and then question 3. Now we have 2 parts. In the first part, it says estimate the temperature of the water after 2 hours. And here's the formula. T of x, which is the temperature, is 20 plus 80 times e to the minus x, and x is the number of hours that a pot of boiling water has been set in a room, or has been sitting in a room of a different temperature. So it says, so basically we're just going to plug in 2, and let's see what we get when we do that. So we have 20 plus 80 times e to the minus x, and x was 2, so it's going to be negative 2. And so it's 30.83. Says round to 1 decimal place, so 30.8. Okay. Now, in part B, you're doing the opposite. Instead of given the time, you're given the temperature. So you're going to plug 60 degrees into this, and then you have to calculate that and solve for x. Let me show you how we do that. That's a little bit more than just plugging in. So let me copy the formula. It's T of x equals 20. T of x equals 20 plus 80 e to the minus x. All right, so let me do that real quick. So we were given the temperature to be 60 degrees. So we're gonna, instead of plugging it in here, because remember, this is the time, we're given the temperature, so it's 60 degrees equals 20 degrees. Okay, plus 80 degrees, e to the minus x. You don't have to write the degrees if you don't want to. Those might just get in the way. Okay. So to solve this, what we need to do is isolate this piece right here. We need to get that by itself so that we can then find x. So I'm going to subtract 20 from both sides of the equation. And that's going to move the 20 over here. So this is going to become 40 equals 80e to the minus x. And then I still need to get this piece by itself. So I'm going to divide by 80. And I get 1/2 equals e to the minus x. So how do we solve this? Well, it's not as hard as it looks. Notice that this is an e base e. So to kind of undo what that is doing to the negative x up there, we're going to take the natural log, which is the inverse function of this exponential function. So we're going to take the natural log of both sides. So let me just write that in red so you can see what I'm doing here. So I'm going to move this, so give myself a little room here. So I take the natural log of both sides. I can do that because I'm doing it to both sides. And there, that gives me the natural log of 1/2 equals, these sort of cancel each other out, minus x. And now to solve for x, I just divide both sides by -1. And I get that x is equal to, so here's the x. That cancels, so I just get x, plain old x. And it's negative, the negative in the denominator can be moved to the numerator. Negative natural log of 1/2. Okay, so doing that on my calculator. I have a natural log of 0.5, which is 1/2. And then I want to take the negative of that. So the answer then is 0.69. Let's see how many decimal places we're supposed to do it to. 2 decimal places. So 0.69. So the natural log of 1/2 is negative 0.69, but then I have a negative here, so it's 0.69. And that is in hours. Because x is the number of hours after it's been put in the room. Okay, let's see here. All right, I hope that going through these problems helps. Question 4. I think it's very similar to the one we just did. Part A, you're just plugging 7 into your formula. And then part B, you take 0.3, which is 30%, 0.3, and then take the natural log of both sides, just like I did in this problem 3.